We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, today we will start the new topic, that is deep level transient spectroscopy. Here this is a new word, spectroscopy. So what is spectroscopy? Spectroscopy is a tool for material characterization from which the interaction between the matter, that is a material of solid, liquid or gaseous form, can be studied with the interaction with the electromagnetic radiation among the wide range of the electromagnetic frequency spectrum like radio waves, microwave frequency range, etc. So what is the purpose of this DLTS method? The full form is deep level transient spectroscopy. The purpose of this method is to determine the impurities and the traps inside the semiconductor. So energetically, the deep trapping levels in semiconductor space charge region affect the performance of semiconductors in terms of shortening of carrier lifetime, enhanced recombination of minority carriers, and output power limitation, and many more. So the shortening of carrier lifetime, that is the most important factor which is affected by the impurities and traps inside the semiconductor, because all the performances of semiconductor depends on the carrier lifetime. And if you are considering the n-type semiconductor and there is a shortening of carrier lifetime, that is of electron, then it is a quite problematic situation for its performance. So characterization of impurities and traps is essential to analyze the performance of semiconductor. This method, deep level transient spectroscopy DLTS, was first introduced by D.V. Lang in 1974. It is commonly used for characterizing the point defects in the semiconductor, and these point defects exhibited in any level of the semiconductor, that means in upper layer, intermediate level, or at the ground level. At any point there is a defect that will be identified using this method. The principle on which the DLTS method is working is the emission of trapped charge carriers which change the depletion capacitance of a PN junction, or we can say a Schottky diode. So basically when the trapped charge carriers will be emitted, and as I told you, the spectroscopy is nothing but the interaction of material and electromagnetic radiation. So what is the information is coming out from the trapped charge carriers and the depletion capacitance will be helpful to determine at what point and at what layer there is a defect inside the semiconductor. The transient measurement, the word comes transient in the DLTS method, is particularly used for providing information of the defect levels in the band gap. We all know there is a band gap in the semiconductor or in the any kind of electronic materials between valence and conduction bands. The most important factor of DLTS method is very sensitive and it is a non-destructive method. So repeatability will be maintained throughout the experiment. DLTS method can also detect traps down to, see this is very important, at the level of 10 raised to 8 per centimeter cube in very good samples. Moreover, electrical properties of defects What kind of electrical defects are there? Number 1, energy position in the band gap. Number 2, capture cross section. And number 3, the concentration of defects. So these all three types of defects can be identified, and further improvement tasks can be carried out to enhance the performance of the tested semiconductor. So this is the deep levels in the band gap working figure, where valence band is there, conduction band, and we can say the intermediate band levels are very important, as they are working as a trap center for holes of the valence band and electrons of the conduction band. First of all, we will focus on the conduction band, where the electron tap center is generated near, or we can say just below, the conduction band. On the opposite hand, we have the hole trap center above the conduction band, and holes and electrons are recombining below the electron trap center and above the hole trap center. So in general, we can say the recombination center takes place near about the Fermi energy level. So recombination centers can interact with both the edges of the band gap. That means here the charge carrier concentration of electrons will be similar to the charge carrier concentration of the holes. Number 2, electron traps. They mostly interact with the conduction band. So here the charge carrier concentration of electrons is much higher than the charge carrier concentration of holes. Number 3, hole traps. They mostly interact with the valence band, and hence the charge carrier concentration of electrons is much lower than the charge carrier concentration of holes. So how we will identify the thermal emission rate through which we can identify the defect inside the semiconductor? So equation number 1, that is En is equal to sigma n, the carrier density, Vn Nc divided by G into exponential minus Ec minus Et divided by Kt. See, this Ec is the energy of the conduction band, Et is the energy of thermal emission from which the electrons are emitting, Vn is the number of charge carriers in the valence band, and C is the number of charge carriers in the conduction band. G is the gravitational constant, K is the Boltzmann constant, T is the absolute temperature of Kelvin. Vn is proportional to the square root of T, Nc is proportional to the cube root of T, that is of temperature, and thus using both the proportionalities we can reformulate equation number 1 as En is equal to sigma n, beta is the proportionality constant, beta T square, because when we multiply T raised to half and T raised to 3 by 2, so we have T square, exponential minus Ec minus Et upon Kt. So this is the DLTS measurement principle, and different stages are there. The first stage is known as equilibrium stage, where the valence band, conduction band and the trap band are at predefined level, or we can say unchanged level. After filling pulse, that is stage B, the charge carrier concentration of electrons is highly increased, and we can see from the figure that the charge carrier concentration of holes is highly decreased. After filling the phase, the return to reverse bias with the change in the capacitance, and the original position of A is somehow stabilized. And in the final emission case, we have the trapped electrons as well as trapped holes in the metal semiconductor junction. So this was the DLTS measurement principle, and this figure is very much important. You have to draw in your GTU examination. So what are the requirements for the DLTS method? The major electrical equipments are necessary for this method are capacitance meter, pulse generator to increase the number of charge carrier concentration in the conduction band, temperature controller, may be liquid nitrogen, helium cryostat or heater, temperature reader, there is a thermometer or digital thermometer, rectifying junction, that is a well-known Schottky or PN junction diode, junction capacitance between the range of 1 to 1000 picofarad, but the most ideal range is of 100 picofarad. Trap concentration less than 10 to 15% of the doping. So the limitation of the DLTS method, we can say, if there is less than 10 to 15% of the doping, only then we can identify the defect inside the semiconductor. And low leakage current and low conduction by maintaining the thermal stability of the same. So this was all about the DLTS method. Thank you for visiting the lecture.